Good morning, students. This is Suresh, Maths faculty from DAV High School, SDSTPS AP Genco, Nelatur. In this video, you are going to learn irrational numbers about pi, representing irrational numbers on number line, real numbers, representing real numbers on the number line through successive magnification related to chapter 1 real numbers class 9. What is irrational number? A number cannot be written in the form of n by d where n and d are integers and d not equal to 0 are called irrational numbers. The collection of irrational numbers are denoted by capital S or Q dash. Or an irrational number can be expressed as a non-terminating and non-recurring decimals. Example, root 2, root 5 and pi, etc. The 5th century BC, the Pythagorean in Greece, the follower of the famous mathematician and philosopher Pythagoras, were the first to discover the numbers which were not rational. These numbers are called irrational numbers. The Pythagoreans proved that root 2 is irrational number. Observe the following table. Root 1 is equal to 1. Root 2 is equal to 1.414213 and so on so. Root 3 is equal to 1.732050 and so on so. Root 4 is equal to 2 and so on so, etc. If n is a natural number other than a perfect square, then root n is an irrational number. Now let us discuss about pi. Pi is defined as the ratio of the circumference of a circle to its diameter. That is, pi is equal to c by d. As pi is in the form of ratio, this seems to contradict the fact that pi is irrational number. There does not exist a common unit to measure that allows us to measure the both. If you measure accurately, then at least either c or d is irrational. So, pi is regarded as irrational. The Greek genius Archimedes was the first to compute the value of pi. He showed the value of pi lies between 3.140845 and 3.142857. Aryabhatta, the great Indian mathematician and astronomer, found the value of pi correctly to 4 decimal places 3.1416. Using high-speed computers and advanced algorithms, pi has been computed to over 1.24 trillion decimal places. The decimal expansion of pi is non-terminating, non-recurring. So, pi is an irrational number. We often take 22 by 7 as an approximative value of pi, but pi is not equal to 22 by 7. The collection of rational numbers and irrational numbers are called real numbers. Set of real numbers is denoted by capital R. Let us discuss locate root 2 on a number line. Solution. Step 1. Draw a number line and mark the center point as 0. Step 2. Mark right side of the 0 as 1 and the left side of as -1. Step 3. We won't be considering -1 for our purpose. Step 4. With the same length as between 0 and 1, draw a line perpendicular to point 1 such that new line has a length of 1 unit. Step 5. Now join the point 0 and the end of new line of unity length. Step 6. A right angle triangle is constructed. Step 7. Now let us name the triangle as ABC such that AB is the height and BC is the base of a triangle and AC is the hypotenuse of the right angle triangle ABC. Step 8. Now length of hypotenuse, that is AC, is found by applying Pythagoras theorem to the triangle ABC. AC square is equal to AB square plus BC square. That implies AC square is equal to 1 square plus 1 square. That implies AC square is equal to 2. That implies AC is equal to root 2. Step 9. Now with AC as radius and C as the center, cut an arc on the same number line and name the point as D. Step 10. Since AC is the radius of the arc and hence CD will also be the radius of the arc whose length is root 2. 11. Hence, D is the representation of root 2 on the number line. Find an irrational number between 3 and 4. Solution. If A and B are two positive rational numbers such that AB is not a perfect square of rational number, then root AB is an irrational number lying between A and B. Therefore, an irrational number between 3 and 4 is root of 3 into 4. That is equal to root 3 into root 4. That is equal to root 3 into 2. We know root 4 value is 2. Therefore, 2 into root 3. One more example. Find three irrational numbers between 3 and 5. Solution. Since 3 and 5 both are rational numbers, therefore the irrational numbers are 3.12719 and so on so, 3.212325 and so on so, 3.969129 and so on so. Examine whether the following numbers are rational or irrational. First question. 3 plus root 3 plus bracket 3 minus root 3. Solution for first question. 3 plus root 3 plus 3 minus root 3, that is equal to 3 plus root 3 plus 3 minus root 3. Cancel the root 3 minus root 3. 3 plus 3 is equal to 6, which is a rational number. Second question. 3 plus root 3 into 3 minus root 3. Solution. 3 plus root 3 into 3 minus root 3. We know that a plus b into a minus b is equal to a square minus b square is an identity. Thus, 3 plus root 3 into 3 minus root 3 is equal to 3 square minus root 3 whole square. Here square root cancel. 9 minus 3 is equal to 6, which is a rational number. Solution for third question. 10 by 2 root 5, that is equal to the numerator and denominator divided by 5 by root 5. That is equal to root 5 into root 5 by root 5. Here numerator and denominator multiple with root 5. So root 5 cancel, then we can get root 5, which is an irrational number since 5 is non-perfect square. Solution for fourth question. Root 2 plus 2 whole square, that is equal to root 2 whole square plus 2 into root 2 into 2 plus 2 square. We know that a plus b whole square is equal to a square plus 2ab plus b square. That is equal to square root cancel 2 plus 4 root 2 plus 4. Add the like terms. 2 plus 4 is equal to 6. That is equal to 6 plus 4 root 2, which is an irrational number. We know the sum of the rational and irrational number is always irrational number. Let us discuss find the value of root 2 up to 3 decimal places by long division method. Solution for root 2. In step 1, first write the 2 in dividend place and put the decimal point. After put 3 pairs of zeros since we need 3 decimal places. Put a bar over every pair of zeros from right side onward. Next, find the largest number whose square is less than or equal to the 2. Here we take 1 since 1 square less than 2 square. So we get quotient is 1 and remainder is 1. Step 2. Bring down the zeros under the bar so the new dividend is 100. 1 is multiple by 2 to get divisor is 2. Step 3. Check the table and nearest 100 is 96. So we get quotient is 1.4 and divisor is 24 and remainder is 4. Step 4. Bring down the zeros under the bar. So new dividend is 400. Now 14 multiple with 2 and get divisor is 28. Step 5. Check the table and select nearest 400. Then quotient is 1.41 and divisor is 281. And the remainder is 119 and bring down zeros, then the new dividend is 11,900. Now 141 multiple with 2 to get divisor is 282. Step 6. Check the table and select nearest 11,900. Then quotient is 1.414, divisor is 2,824 and remainder is 604. Therefore, root 2 is equal to 1.414 and so on so. Let us discuss successive magnification method. The process of visualization of numbers on the number line through a magnifying glass is known as the process of successive magnification. Now let us solve one problem. Example 11. Visualize the representation of 3.58 bar on the number line through successive magnification up to 4 decimal places. Solution: 3.58 bar means 3.5888 and so on so. Since 8 has bar, according to problem, 4 decimal places of 3.58 bar is equal to 3.5888. Step 1. 3.5888 is lies between 3 and 4. So we divide the line into 10 equal parts between 3 and 4 and mark numbers 3.1, 3.2 and so on. But 3.5888 lies between 3.5 and 3.6. So round off 3.5 and 3.6. Step 2. Between 3.5 and 3.6 divide into 10 equal parts and first mark represent 3.51, second mark represent 3.52 and so on. But 3.5888 lies between 3.58 and 3.59. So round off 3.58 and 3.59. Step 3. Between 3.58 and 3.59 divide into 10 equal parts and first mark represent 3.581 and second mark represent 3.582 and so on. But 3.5888 lies between 3.588 and 3.581. So round off 3.588 and 3.589. Step 4. Between 3.588 and 3.589 divide into 10 equal parts and first mark represent 3.5881 and second mark represent 3.5882 and so on. 3.5888 is the 8th mark in these subdivisions. So round off 3.5888 on number line. This process of visualization of presentation of numbers on the number line through a magnifying glass as the process of successive magnification. We will discuss some more problems in the next video. Thank you.